On the morning of June 30th, 1908, the remote Siberian wilderness was waking to a calm summer day. At approximately 7:17 in the morning local time, a strange, brilliant light streaked across the sky, described by witnesses as a bluish ball with a fiery tail or a diffuse glowing star. Indigenous Evenki people and Russian settlers watched in astonishment as the light moved at incredible speed across the horizon, culminating near the Podkomenaya Tunguska River. Moments later, the sky erupted in an enormous blast, generating a pillar of fire and a cloud of dark smoke. The shockwave from the explosion was so powerful that it knocked people off their feet over 60 kilometers away, shattered windows, and registered on barometers as far as England. One man, S. Semenoff, sitting on the porch of a trading post 65 kilometers from the explosion, reported being thrown several feet and feeling an intense heat that seemed to set his clothing alight. Despite the enormous energy released, estimated to be up to 1,000 times that of the Hiroshima atomic bomb, the event went largely unnoticed by the outside world due to the region's isolation and sparse population. Over the following nights, a strange atmospheric phenomenon occurred, a lingering glow in the sky across Asia and Europe, allowing people to read newspapers outdoors at midnight, signaling that millions of tons of dust and ice had been thrown into the upper atmosphere by the blast. Although the Tunguska explosion occurred in 1908, the wider scientific world did not fully investigate the event until over a decade later. In 1921, Russian mineralogist Leonid Kulik began collecting eyewitness accounts and reports, determined to uncover the truth behind what locals described as a falling star and a devastating explosion. His initial survey faced incredible challenges. The suspected impact zone was hundreds of kilometers from the nearest railway, and the Siberian wilderness was filled with dense forests, swamps, and rivers. Kulik's first attempt to reach the area failed, but he returned persistently, aided by local Evenki guides who knew the terrain intimately. By 1927, nearly 2 decades after the explosion, Kulik and his team finally reached the site. What they discovered was shocking. The forest over an area of more than 2,000 square kilometers had been flattened, yet not in a uniform manner. Trees were knocked down in a radial pattern, pointing away from a central point, creating a butterfly-shaped devastation visible even from aerial photographs years later. In the very center of the blast, however, the trees were not uprooted. They stood like scorched telegraph poles, stripped of branches and bark but otherwise intact. There was no crater, no fragments of a meteorite, and no conventional evidence of impact. The destruction was complete. Yet paradoxically, the source of the energy remained invisible. Kulik meticulously documented these observations, measuring tree fall patterns and marking the radial extent of the devastation. He drained small bogs and examined depressions, suspecting impact craters, but found nothing. The more he investigated, the clearer it became that this explosion had been unlike anything seen before. An immense release of energy in midair, leaving a giant swath of destroyed forest, but no tangible object behind. This journey highlighted both the scale of the catastrophe and the enduring mystery of what had caused it. The remoteness of the Tunguska site, combined with the sheer magnitude of the destruction, delayed scientific understanding for decades. Even after Kulik's expeditions, the world had only glimpsed the enormity of the event through reports and photographs. His findings laid the foundation for decades of investigation, giving scientists the first clear evidence of an unparalleled atmospheric explosion that challenged traditional ideas of meteoric impacts and left the Siberian wilderness a silent testament to nature's raw power. After Kulik's groundbreaking expeditions in 1927, scientists began to piece together what might have caused the Tunguska event, but the puzzle was far from complete. The most widely accepted explanation that eventually emerged is known as the airburst hypothesis. According to this theory, the Tunguska object, either a stony asteroid or an icy comet, never actually impacted the ground. Instead, it entered Earth's atmosphere at an extremely high speed, estimated to exceed 50,000 kilometers per hour. The immense friction and pressure caused the object to heat up, disintegrate, and explode in midair, roughly 5 to 10 kilometers above the forest canopy. This midair explosion explains several of the baffling observations from the site. The trees at ground zero were stripped of branches and bark, but left standing, while the surrounding forest was flattened in a radial, butterfly-shaped pattern. The airburst released energy equivalent to approximately 10 to 30 megatons of TNT, hundreds of times more powerful than the bomb dropped on Hiroshima. Shock waves from the explosion were recorded by barometers as far away as England, demonstrating the extraordinary reach of the blast. Unlike typical meteorite impacts, no large fragments of the Tunguska object survived to reach the ground, which is why Kulik and later scientists could not locate a crater or recover meteorite pieces. Evidence supporting the airburst theory continued to accumulate over the decades. Analysis of tree resin and peat bog layers from the area revealed microscopic silicate and magnetite spherules, enriched with nickel, a hallmark of extraterrestrial material. Elevated levels of iridium, a rare element often associated with asteroids, were also detected in soil layers dating from 1908. Together, these findings reinforced the conclusion that a cosmic object had exploded in the atmosphere rather than striking the Earth directly. The airburst theory also gained a modern parallel with the Chelyabinsk meteor in Russia on February 15, 2013. A roughly 20-meter asteroid exploded in the atmosphere, shattering windows and injuring over 1,500 people. Though much smaller than Tunguska, the Chelyabinsk event provided a tangible example of how an object could release massive energy in midair without creating a crater. By comparing Chelyabinsk to Tunguska, scientists were able to refine their models, estimating the energy, altitude, and trajectory of the Tunguska explosion with greater accuracy. Despite this consensus, questions remained about the object's composition. Was it a dense, stony asteroid, a fragile comet, or a rare type of iron-rich meteoroid? Computer simulations suggested that a stony body between 50 and 80 meters in diameter best matched the observed damage patterns and energy release. Some researchers proposed that a large iron asteroid might have grazed the atmosphere and partially skipped back into space, but this scenario remains speculative. Regardless of the exact type, the evidence increasingly pointed to a cosmic origin and a high-altitude detonation as the explanation for the unprecedented destruction. By the mid-20th century, the Tunguska event had become a benchmark for understanding atmospheric explosions of cosmic objects. Scientists recognized that such airbursts could cause massive regional damage without leaving conventional impact evidence. The mystery of the missing crater, once baffling Kulik, was now explained by a combination of velocity, altitude, and the object's explosive disintegration in the sky. Yet even with this mainstream explanation, the event retained an aura of the strange and inexplicable, a reminder that nature could unleash incomprehensible power far above the ground, leaving almost no trace of the weapon that had done it. The Tunguska event also prompted renewed interest in planetary defense. By studying past airbursts and near-Earth objects, scientists began to understand the potential threat such events pose to populated areas. Today, Tunguska serves as both a historical oddity and a cautionary tale, a cosmic event capable of leveling vast tracts of forest, demonstrating the fine line between natural wonder and catastrophic destruction. Even with the airburst hypothesis providing a solid scientific explanation, the Tunguska event continued to fascinate and confound both scientists and the public, inspiring numerous fringe theories. The lack of a crater and the near total disappearance of the object left room for speculation that ranged from the imaginative to the outright fantastical. One of the most enduring ideas was that the explosion had been caused by a crashing extraterrestrial spacecraft. Sci-fi author Alexander Kazantsev, writing after the atomic bombings of Hiroshima and Nagasaki, suggested that a UFO powered by a nuclear engine might have detonated over Siberia. He pointed to the radial destruction pattern and the intense energy release as evidence, comparing it to a small-scale nuclear explosion. While visually compelling, there is no empirical evidence to support this claim, and it remains purely speculative. Another proposed explanation involved exotic physics. In 1973, some physicists hypothesized that a miniature black hole could have passed through the Earth at Tunguska, creating a catastrophic shockwave without leaving any conventional impact evidence. In this scenario, the black hole would have entered the atmosphere, released an immense amount of energy, and exited on the opposite side of the planet. Although theoretically testable, predicting disturbances or energy signatures at the exit point, no such evidence was ever observed, making this idea extremely unlikely. A third, equally speculative theory involved antimatter. Scientists proposed that a small chunk of antimatter might have collided with the Earth, annihilating itself and releasing enormous energy while leaving no debris. In practice, large amounts of antimatter do not naturally exist in our solar system, making this explanation virtually impossible. yet it persisted in popular discussions, largely because it accounted for the total disappearance of the object. Even Nikola Tesla was pulled into the conversation. Some conspiracy theorists claim that Tesla had been testing a long-range wireless energy weapon, a death ray, and that the Tunguska blast was an accidental discharge directed at the unpopulated Siberian wilderness. Proponents imagine that Tesla had attempted to bounce massive electrical energy off the ionosphere and inadvertently triggered the explosion. While this theory is dramatic, there is no credible historical evidence linking Tesla to the Tunguska event, and it remains a modern myth. Other ideas included natural but unusual phenomena, such as a massive volcanic gas explosion from a previously unknown Siberian vent, or a sudden release of methane from permafrost. Both were largely discounted because no supporting geological evidence was found, and the radial tree fall pattern matched a high-energy aerial explosion rather than a ground-based release. Despite the lack of supporting evidence, these fringe theories served an important role in the public imagination. They highlighted how a single unexplained event could challenge conventional thinking and spark creative, if scientifically unsupported, explanations. The combination of immense power, the absence of physical remnants, and the sheer isolation of the event contributed to Tunguska's reputation as one of the weirdest events in recorded history. Ultimately, while these alternative explanations are intriguing, they cannot compete with the airburst hypothesis, supported by modern measurements, chemical analysis, and computer modeling. Nevertheless, the persistence of these ideas illustrates the deep human desire to understand mysteries that seem almost supernatural. Tunguska became more than just a historical explosion. It became a symbol of the unknown forces that lurk above our planet, waiting for a rare, devastating moment to remind humanity of its vulnerability. After more than a century of study, the scientific consensus has largely settled on the Tunguska event being caused by the airburst of a cosmic body, likely a stony asteroid or comet, that exploded in the atmosphere without ever touching the ground. Detailed computer modeling suggests the object was between 50 and 80 meters in diameter and detonated with the energy of 10 to 30 megatons of TNT. This mid-air explosion explains the unique butterfly pattern of flattened trees, the standing but scorched trees at the epicenter, and the absence of a crater. Subsequent expeditions to the site uncovered tiny silicate and magnetite spherules embedded in soil and tree resin. These microscopic spheres contained elevated levels of nickel, a classic indicator of extraterrestrial origin. Analysis of peat bogs in the region also revealed a distinct layer dating to 1908 with higher than normal concentrations of iridium, an element rare on Earth but common in meteorites. These findings strongly support the hypothesis that a cosmic object entered Earth's atmosphere and exploded, leaving only trace evidence of its presence. The Chelyabinsk meteor in Russia, which exploded in February 2013, provided a modern analog. At about 20 meters in size, it created a powerful airburst that shattered windows and injured over 1,500 people, demonstrating on a smaller scale how a fast-moving object can release enormous energy in the sky. Scientists now understand that such airbursts can flatten forests, create shockwaves over hundreds of kilometers, and produce bright, lingering atmospheric effects without leaving a crater. Debate continues over whether the Tunguska object was a comet composed mostly of ice or a denser, rocky asteroid. Some models suggest that a cometary body would account for the bright, glowing skies observed across Europe and Asia for several nights after the explosion. However, most recent analyses favor a stony asteroid, based on calculations of density, entry angle, and energy release, which better explain the pattern of destruction observed in the Tunguska forest. Beyond solving the mystery of Tunguska itself, this event has become a crucial case study for planetary defense. Scientists use the data to model potential near-Earth object impacts, simulate atmospheric explosions, and develop early warning systems. Tunguska illustrates that even relatively small cosmic objects can unleash destruction comparable to the largest nuclear weapons. The event also serves as a cautionary reminder of how rare but high-impact cosmic phenomena can threaten human civilization. It underscores the need for continued investment in asteroid detection, monitoring, and, if necessary, deflection technologies. International efforts, including NASA's DART mission and other planetary defense initiatives, aim to prevent future disasters on a global scale. While the mystery of Tunguska has largely been resolved scientifically, Its legacy continues to inspire awe, caution, and curiosity. It reminds humanity that Earth is not isolated from the cosmos, and that even the most remote and sparsely populated regions are vulnerable to forces far beyond human control. Tunguska remains a singular example of a natural event that is as educational as it is terrifying. The Tunguska event of June 30th, 1908 remains one of the most bizarre and unsettling occurrences in modern history. While scientists have largely confirmed that a mid-air explosion of a cosmic object caused the devastation, the sheer scale and unusual characteristics of the event continue to capture imaginations. From the flattened forests over 2,000 square kilometers to the standing but scorched trees at ground zero, every detail underscores the extraordinary force released by the explosion. The event also serves as a stark reminder of humanity's vulnerability to cosmic hazards. Objects in space, even relatively small ones, can release energy equivalent to dozens of nuclear bombs without warning. Had the Tunguska object exploded over a populated city instead of the remote Siberian wilderness, the consequences could have been catastrophic, potentially killing tens of thousands and causing unimaginable destruction. This scenario illustrates why planetary defense is not just theoretical. It is a real, urgent priority for scientists worldwide. Since Tunguska, international space agencies have invested heavily in detecting and tracking near-Earth objects. Programs like NASA's DART mission, which successfully altered an asteroid's trajectory, show that technological solutions exist to mitigate potential threats. Additionally, global awareness campaigns such as International Asteroid Day on June 30th educate the public about the dangers of space hazards and the importance of scientific monitoring. The Tunguska explosion also continues to fuel curiosity and debate. Fringe theories, from alien spacecraft to miniature black holes, may have no scientific basis, but they highlight how a mysterious event can inspire both wonder and speculation. In reality, the true story is compelling enough: a cosmic visitor traveling millions of kilometers through space, disintegrating in our atmosphere, and leaving behind a scar on the Siberian forest that remains visible more than a century later. Even today, researchers revisit the Tunguska site, studying tree rings, soil layers, and atmospheric data to refine models of airburst phenomena. These investigations help predict how similar events might unfold and improve our understanding of the physics behind cosmic explosions. Every new piece of data reinforces the lesson that Earth exists in a dynamic and sometimes dangerous cosmic environment. Ultimately, the Tunguska event is a reminder of both the fragility and resilience of life on Earth. While it exposed how vulnerable human settlements can be to rare cosmic phenomena, it also prompted scientific innovation and preparedness that could save countless lives in the future. By studying the past, humanity learns to anticipate and survive potential threats from beyond our planet. The legacy of Tunguska is therefore twofold: a chilling historical record of one of nature's most powerful airbursts, and a continuing call to vigilance, research, and planetary defense. It is a story of mystery, destruction, and scientific triumph, an event that transformed a quiet Siberian wilderness into a cautionary tale for the entire world. The memory of that bright, terrifying morning on June 30th, 1908, remains etched into both the Earth and human consciousness, serving as a final warning from the cosmos itself.